So the one thing that should kind of stand out to you as a problem that is a good one to solve by elimination is usually if they are in standard form, where you have an x term plus or minus a y term equals a constant term, then that's going to be a good one to solve by elimination. Okay. Also, if I were going to solve this one by substitution, what about this makes this a big pain for me to solve by substitution?
There's no variable that's alone.
There's no variable that's by itself, right? Which means if I were going to try and solve it for x here, I would have to first add 4y, and then I'd have to divide by 9, which is going to give me a fraction because 4 and 3 are not divisible by 9. Okay? Or if I were going to solve it for y, I'd have to subtract 9x over and then divide by negative 4. Once again, 9 and 3 are not divisible by negative 4, so it's going to give me a fraction. So each one has different advantages to it. So elimination's a really good one to use if you have numbers that are not variables by themselves. Okay? And it's helpful if it's in standard form because then you have x terms lined up, y terms lined up, and constant terms lined up. Because just like with anything else, in algebra, we can only add things if they are like terms, right? So I can't add an x term to a y term. Well, I mean, I can. I just can't simplify it, right? So anytime you see them lined up standard form, especially if the variables all have coefficients with them, then that's probably a good indication that, hey, you might want to do this using elimination. Now, for elimination, the important thing is that you have the same coefficient or opposite coefficients on your variable. For instance, I could either have 9x and 9x, or I can have 9x and negative 9x. The difference is I want it to go away, which means if they're opposites, I need to add them together, because 9x plus negative 9x is 0, right? If they're the same thing, if they're 9x and 9x, then I would subtract, because 9x minus 9x. So the only difference in whether they're the exact same thing or whether they're the opposites are whether you add the two equations or subtract. So here I have 9x minus 4y equals negative 3, and then I have negative 9x plus 7y equals 12. So since they're opposite signs with the same number, I'm going to add them. So I'm going to do 9x plus negative 9x is 0x. So that eliminates, thus the elimination method, right? We're just eliminating our x terms, which leaves me with negative 4y plus 7, which gives me 3y, and negative 3 plus 12, which gives me 9. Now I have a one-step variable equation, right? So I'm going to divide by 3, and I get y equals 3. Then, just like on all of our others, if I know what y is, I can plug in to either equation. It doesn't matter. So I can plug it into this one, or I can plug it into that one and solve for x. So which one do you want to plug it into? The top one? All right. So 9x minus 4y equals negative 3. But I'm going to replace y with 3. So I'm going to say times 3. And then I'd need to multiply first. So 9x minus 12 equals negative 3. And then I need to add 12 on both sides. So I get 9x equals 9. And then if I divide by 9, I get x equals 1. So my solution is x is 1, y is 3. Right? Now, one thing that I forgot to mention to you guys, that y'all are probably going to kill me now that I mention it, but one thing that's important about solving equations, whether they be linear equations or regular equations, is that there's a nice thing that you can do at the end to make sure you have the right answer. Right. we can plug it in. The whole point of solving a system of equations is what x and y value will make both equations true. So if you want to make sure you've got the right answer, you can plug it in. So I had x is 1, y is 3, right? So I can take my first equation, 9x minus 4y equals negative 3, and I can replace x with 1, so 9 times 1 minus 4 times 3 should equal negative 3. So 9 times 1 is 9, 4 times 3 is 12, and 9 minus 12 is negative 3. So it works for the first equation. And then I can do my second equation, negative 9x plus 7y equals 12. So negative 9 times 1 plus 7 times 3 should equal 12. So that's negative 9 plus 21, and negative 9 plus 21 is 12. So the second equation works. So that way you can make sure that your answer is correct. So good thing to know when you've got a test coming up Friday that, hey, when you think you've got your final answer, you can double check your answer by plugging it in and making sure that it does in fact work for both equations. All right, so let's look at just one more example. So let me enter this one in and then I'll get another one off of here. All right, one key difference in this one is what? The variables are the same, right? Which means you would need to
multiply by negative 1.
Okay, you can subtract them, or I really like adding better, so I would do what Laura did. I would actually multiply through by negative 1 on one of them. I prefer having them be opposites. That way I can think of it as addition, because, you know, a lot of times subtracting with negatives, it's easy to get confused and do the wrong thing. So I think it's easier to add. That way, even if it's negatives, most people are more comfortable adding with negatives. So my preference is to simply multiply one of the equations through by negative 1. Now, on the last example on the video last night, we talked about how you can do this. Remember, anything you do to one side of the equation, you do to the other, and as long as you do it to both sides, then the two sides are still equal, right? So as long as I multiply everything, this side by negative 1, which is going to use distributive property, so I'm really multiplying this times negative 1 and this times negative 1, and also this side by negative 1. As long as I do that, the equation is still going to be true, right? So my equations would look like negative 6x plus 2y equals 12. And then if I multiply this one through by negative 1, then instead of negative 6x, I'll have positive 6x. Instead of plus 5y, I have minus 5y. Instead of negative 15, I have positive 15, right? So the nice thing about multiplying through by a negative is all it does is change all of your signs, right? Yes, Olivia?
How do you know when to use the negative?
The only reason I'm multiplying through by a negative is because here I have negative 6x and here I have negative 6x. I want them to have opposite signs so I can add them. Again, you can do it as a subtraction problem, but what I have found is that more people make careless errors with subtraction. So my preference is make them the same, or make them opposite signs. That way it's an addition problem. So now that I have opposite signs, now I can just add the two together, because negative 6x plus positive 6x is 0x. So my zero term is eliminated. 2 plus negative 5 is negative 3. And 12 plus 15 is 27. So I get negative 3y equals 27. And then I'm going to divide through by negative 3. And I get y equals negative 9. So that's the first half. And then I'm going to plug into one. So which one do you want to plug into?
First one.
The first one? Okay. So I'm going to plug into my first equation. So negative 6x plus 2y equals 12. But I'm going to replace y with negative 9. So 2 times negative 9 is, so I'll have negative 6x minus 18 equals 12. And then from there, add 18 to both sides. And I get negative 6x equals 30. And then, I always run out of room. I keep forgetting to make it bigger. So then, divide by negative 6 on both sides. And we get x equals negative 5, right? So my solution here is negative 5, negative 9. And again, you can check your answer. And guys, with a calculator, it's really easy. You can do negative 6 times, scientific calculator will even do order of operations for you. So you can type in negative 6 times negative 5 plus 2 times negative 9, hit enter, and it should equal 12. And then you can do negative 6 times negative 5 plus 5 times negative 9, and it should equal negative 15. So it's a really quick check in your calculator to just plug them in and make sure that they work out. And then you have 100% certainty that your solution is correct. And of course, obviously, if they don't work out, then that tells you you need to go back and look in your math and see where you've made a mistake. All right, yes? Why can't I add 6 to what? You mean right here? Hang on.